This lesson is over solving linear equations. Solving linear equations. Well, first we need to know what exactly is an equation. An equation is where two expressions are equal. Think of it as the left side must equal the right side. Now, solving is actually the process of finding the solution of an equation. Notice the word process. It will take a while to do this. Now, a linear equation in one variable is of the form ax plus b equals c. And the technicality states where a cannot equal 0. But the important thing you may notice is it says in one variable. Well, what does that mean? It means you will have one variable, such as x, somewhere along in the equation. And that variable will be what you're trying to solve for. The first property we're going to talk about is the addition property of equality. Say we were to have the equation a equals b. But if I choose to add c on both sides and make it a plus c equals b plus c, well, these equations would be known as being equivalent, or the same value, a true statement. Now, the same is true if I have the equation a equals b, but in this case, I subtract c on both sides of the equation. These are also known as equivalent equations. A equals b holds the same value or same true statement as a minus c equals b minus c. So to summarize, it means the same number may be added or subtracted from both sides without changing the solution. Example 1, solve. For a, we have the equation x plus 5 equals 9. Now notice this is an equation because we see an equal sign. So I like to draw a line at the equal sign so I know my left side from my right side. Now look at the equation. We want to solve for the variable. In this case, what is our designated variable? Well, in this case, it happens to be x. So we look on the side that has the x, which happens to be the left side of the equation. Currently, x plus 5 is on the left side. Well, I need to get rid of that adding of 5. So what is the opposite operation? Well, we would need to subtract 5 on both sides. To be fair, I would need to subtract 5 on the left side and on the right side. By doing that, we can now simplify each side. 5 minus 5 cancels, leaving you with x, and 9 minus 5 leaves you with 4. And so you now have x equals 4. For example B, we have 21 equals m minus 7. Now notice this is an equation because we have an equal sign. So again, I will draw my line at the equal sign so I see my left side and my right side. In this case, I want to identify my variable, which in this case is an m. Now notice m is on the right side of the equation. So I want to isolate m, but to do so, I need to get rid of this minus 7. So what is the opposite operation of minusing 7? Well, that would be to add 7. We must add 7 on the right side as long as we do it to the left side as well. And so negative 7 plus 7 cancels, leaving you with m, and we know 21 plus 7 is 28. So that would be your solution. Now we've looked at some introductory problems. Here's a bigger problem. For C, we have the problem 10w plus 3 minus 4w plus 4 equals negative 2w plus 3 plus 7w. Now notice, this is an equation, so we draw our line at the equal sign. Now I'm sure you agree, this equation has a lot more going on than the two previous examples. So what we want to do is we want to look at one side at a time. So cover up the right side of the equation and only focus on the left side. And what we notice is we have some like terms. Notice I have a 10W minus a 4W. Those can combine to give me 6W. Now I notice my constants or plain numbers. In that case, I have a 3 and a positive 4. If I combine them, that gives me plus 7. So I've been able to simplify the left side of the equation down to these two simple terms, 6W plus 7. Now we uncovered the right side, and now we're going to try to simplify the right side of the equation. So we cover the left side so we don't get distracted. On the right side, notice I do have some like terms of negative 2W and a positive 7W. Together give me a positive 5W. Now for constants, I only have that plus 3, so it will stay. That's all that we can do, so we remove the post-it, and now this is our current equation. 6W plus 7 equals 5W plus 3. Now in this instance, we have variables appearing on the left side and the right side. So we have to make a choice. What side do you want your variables to be on, left or right? Well, in this case, let's try moving our variables to the left side of the equation. Since 5W is on the right side of the equation, and I want to move it to the other side, I need to undo its current operation. Since that is a positive 5W, to undo that would mean to subtract 5W. But I can only do that as long as what you do to one side, you must do to the other. Now we simplify each side of the equation. On the left, we have 6W minus 5W, which simplifies to leave you with W plus 7. And on the right side, the 5W's cancel, leaving you with just 3. Now notice we had W's on different sides of the equation. They have now been combined to a single side, so that's good. But now we need to get W completely by itself. So on the side with the variable, with W, what do we need to get rid of? Well, we need to get rid of adding 7. And so the opposite operation would be to subtract 7. As long as what you do on one side, you must do to the other side. And we know 7 minus 7 would cancel, leaving you with W, and 3 minus 7 would leave you with negative 4. Example D. Negative 3 equals 3 times the quantity 2x minus 5 minus the quantity 5x plus 1. Now again, this is an equation, so we draw a line at the equal sign, and we want to simplify each side individually. Well, on the left side, you only have a negative 3, so it must stay. However, on the right side, we have quite a few things happening, so let's work through it slowly. Notice we have a 3 touching the parenthesis of 2x minus 5. Well, recall, if values are touching, that implies multiplication, which means we need to distribute the 3. So 3 times 2x and 3 times negative 5. Well, that gives us 6x minus 15. Now the 3 stops distributing because we reached the end of the parentheses. And so now we have minus the quantity 5x plus 1. Because that minus is in front of the parenthesis, you can read that as distributing a negative 1 or as the opposite of. So what is the opposite of 5x? What is the opposite of positive 1? Well, that would give you negative 5x minus 1. Now, still only looking on the right side of the equation, notice we have like terms that we can put together to simplify. 6x minus 5x can combine to give you x, and negative 15 minus 1 can combine to give you negative 16. So we've officially simplified the right-hand side of the equation. So now we look at the problem as a whole. We're trying to solve for x. Now notice x is already on one side of the equation. That's great for us. Now only looking on that side, we need to remove anything that does not have a variable. Now notice we have a minus 16. Well, we need to undo that operation. Well, to undo subtracting 16 means you must add 16, as long as what you do to one side, you must do to the other. And so negative 3 plus 16 gives us 13 equals x. And that would be your solution. For example E, we have negative 2 times the quantity x plus 1 plus 3x equals 14. Again, this is actually going to be your try it problem. Let's see how you did. Hopefully you found x to equal 16. Now we've talked about the addition property of equality. Now we're going to talk about the multiplication property of equality. So again, say we have the equation A equals B. But this time, what if we multiply both the left side and the right side by a value of C? Well, what that does is it means these two equations are equivalent. The same is true as if I had the equation A equals B and I decided to divide the left side and the right side by a value of C. These two equations would also be considered equivalent. In other words, the same number may be multiplied or divided from both sides without changing the solution. Example 2, solve. For A, we have 7x equals negative 42. Now notice this is an equation, so I draw a line at the equal sign. Now we're trying to isolate and solve for x, so find the side that x happens to be on. Is it the left or is it the right? In this case, x is on the left side. So only looking at the left side, notice you have 7x. Because 7 is touching the x, that means that they are multiplying. So what we need to do is we need to undo that operation. So to undo multiplication means we need to divide. So if we divide the left side by 7, that is okay, as long as what you do to one side, you must do to the other. And so 7x divided by 7 leaves you with x. And on the right side, negative 42 divided by 7 leaves you with negative 6. For B, we have y over 5 equals 13. Again, I draw my line at the equal sign. Now, identify the side that the variable happens to be on. Is it on the left or the right? Well, it is on the left. Now notice, what is happening between the y and the 5? Well, we can read that as y divided by 5, but what is the opposite operation of division? Well, that would be multiplication. So we are going to undo that by multiplying the left side of the equation by 5, as long as you multiplied the right side of the equation by 5. Because we undid the operation on the left side, it does reduce to give you y. And on the right side, 5 times 13 gives you 65. For C, we have 3 over 7. A equals 9. Again, draw your line at your equal sign. Now this one is slightly different. This time the variable is off to the side, but we do have a fraction. We have 3/7 times a. Now because this is kind of a messy looking fraction, what we do is we actually multiply by the reciprocal of the leading fraction. Now remember, reciprocal means to simply flip the fraction. So in front of a, I currently have 3/7, which means the reciprocal would be 7/3. That's okay if I multiply the left side by 7/3, as long as I must also multiply the right side of the equation. Now on the left side, notice I have a 3 in the numerator and a 3 in the denominator. That means the 3's reduce. I also have a 7 in the numerator and a 7 in the denominator. Those reduce, leaving me with a. Now on the right side, 7/3 times 9 is the same thing as 7/3 times 9/1. Now because we're multiplying fractions, we do multiply top times top and bottom times bottom, but I also want to see all the factors. So I can rewrite it as such as 7 times 3 times 3 all over 3 times 1. Now notice I do have common factors that appear in the top and the bottom, but there's no other common factors. So your answer will be a equals 21. We're going to look at some steps about how to solve multi-step equations. First, simplify each side of the equation following GEMS, meaning look for grouping symbols, any exponents, multiplication or division, subtraction or addition. Step 2, if necessary, get the variable on the same side using the addition property of equality. Meaning if you have x's on both the left and the right side, pick a side and then use the addition property to get the variables on the same side. Step 3, now that all the variables are on the same side, remove any terms that do not have the specified variable by using the addition property of equality. Step 4, to isolate the variable, use the multiplication property of equality. And remember, you can check your answers by plugging them into the original problem. For D, we have negative 7x plus 2x equals negative 3 plus x plus 20 minus 5. Again, draw your line at the equal sign. Now, step 1 says to use GEMS on each side individually, which simply means to simplify each side. Looking at the left side, notice you do have like terms. Negative 7x plus 2x can combine to give you negative 5x. On the right side, you have just x's, nothing else to combine with, but you do have several constants. Negative 3 plus 20 minus 5 does combine to give you a positive 12. So we've done step 1 by simplifying each side. Now step 2 says, if necessary, get your variables on the same side. Well, looking at the problem, notice we have x's on the left side and on the right side. So we have to get them on the same side. Let's try to move all x's to the left side of the equation. Well, that means the one on the right side, that x plus 12, we need to undo the operation of x. So how do you undo a positive x? You have a negative x, which means you subtract it, as long as what you do on one side, you must do to the other side. And so from here we see negative 5x minus x can combine to give you negative 6x, and on the right side we're left with the 12. Now that we have the variables together on the same side, now we want to completely isolate and get x by itself. So examine what's happening between negative 6 and x. Are they adding, subtracting, multiplying, or dividing? Now looking at the clues, because they're touching, that means they are currently multiplying. So what's the opposite operation? Well, that would be to divide. Divide the left side by negative 6 and the right side, and you should find that x equals negative 2. For E, we have x over 3 plus 2 equals negative 5. Again, this case is going to be your try it problem. Hopefully you found x to equal negative 21.